Hey everybody, we are here now and you should find the code in the usual spot it's in where we usually put the code to make sure we're not posting the code out there lest we get bombarded. Hey everybody, good to see everyone. I'm taking a look. Let me see how many people are in the game. Right now we have 18 people. Let's try to get up to like 50 or so. That'll be a fun number. How many people do we have watching? I can't see. Happy Saturday everyone. Good to see everyone. We'll get started here in just a moment. Are there any questions about the exam? We got 37 watching, 36 people watching. Yeah. What's up, Emily and Mattingly and everybody? We have the code in our usual spot. Cool, Jay. We got the usual spot for our code right there. That's the best I can say about it. So your teachers should definitely have informed you throughout the semester where to find the code. That way we can make sure. Will the final be similar to past exams? Yes, it'll be the same format as multiple choice. You'll have to do interpretations of confidence intervals. You'll have to do other sorts of, interpreting your results after a test. So you'll notice today a lot of your answers, I think there's 2 answers that are like say your answer out loud and you get credit for just saying that you said your answer. And hopefully I didn't mess up any of the buttons on the Kahoot. We have 28 people in the Kahoot right now. And so, but there's a lot of like write out your answers and make sure you interpret things properly. So make sure to do that. The code is life. Life is the code. That is a great code. And I think we're good on audio levels. I got everything set up today. Good. And you guys ever tell me, feel free to tell me audio is too loud, it's too quiet, it's getting a little, if you hear weird sort of peaking, we call it an audio. Audio is great, awesome. We're actually going to work on getting a better mic. How to interpret the chi-squared test. I think I have some chi-squared tests on here, so we can do some interpretations of the chi-squared test of independence. Great question right there, Joe. So great questions. We'll wait till about 12:05 to start the Kahoot review. The chi-squared test of independence, remember that the null and the alternative, the null is that the two things are independent of each other, and the alternative is that they are not independent. So when you talk about the chi-squared test of independence, always set up your null and alternative properly, and then when you reject the null, you would say, I reject that these two things are independent. I have evidence that they are not independent. And by not independent, we mean that they're associated. Imagine if someone told you, this would be really scary, like we do version A and version B of the test. If someone said your grade is associated with the version of the test you take, and that's not what we want. We don't want your grade to be associated with the version of the test. We want it to be independent of the test you take. And although you could say making an A, let's say make an A or an F, now it's categorical, like the grade you get, A, B, C, D, F, A, B, C, D, F, would be independent. Did they? I did not hear that, Josh. That is too funny, Josh. Oh my gosh, Josh has a new nickname. That is too funny. Good to see you in here, Josh. One of these days, I think I brought you down to the studio to check it out. Yes, do take notes during the Kahoot. Your main focus should not be winning the Kahoot, but taking notes during the Kahoot. And Josh, you should definitely join in on the Kahoot if you want. See how you do. You can't win the $5 Starbucks gift card. I think we still have a $10 one. I accidentally gave one of the winners a $5 one, so I might have 2 $10 ones, and that winner is welcome to come back by and pick up another $5 Starbucks gift card. But I should have written on the outside of them, what was it? What is our main focus in winning the Kahoot? What if your main focus is winning the Kahoot? Well, then do that. I mean, you can get an A in the class, or you can win a $10 Starbucks gift card. Your call. Take your pick. If you want to put all your attention to that Starbucks gift card, I can't change where your focus is at. Let's give the Kahoot. Ask questions if you got them right now. Unless winning the Kahoot, I would say, is not independent of how you do in the class. So your grade in the class, like how you do in the Kahoot, is not independent. I have evidence that these Kahoots have helped. Many people have told me the material we cover in this Kahoot, so people might be watching it right now in the future. Please be taking notes, be thinking about what I'm trying to cover, and I always want to pause after every question to make sure you understand what we're doing. Also, if my mic stops at any point, and I know you'll do it in the chat, please tell me. I was on 2 bars of battery for both my wireless part and the wireless receiver. So if at any point my mic goes out, be like, your mic's out, and I'll be like, what? And then you'll see me grab batteries over here on the side and start putting in new batteries into the mics. But we also have one of the podcast mics. I'm trying to get us to have a really awesome studio mic, especially for next semester. So although we have really great quality of voice right now, we're gonna have even better. We're gonna have like one of those amazing podcast mics where it's like literally perfect audio, we hope. If you're not first, you're last. Ricky Bobby got it right. You know, any movie with Will Ferrell, you just gotta, it's Will Ferrell talking through Ricky Bobby, and you know, he knows all. Will Ferrell is everything. Let's go. Let's see. I want to see if we hit 40 players. I'm going to start it. That's like our goal. If we hit 40 players, let's start. We're at 36 players. So what's going to happen when I hit start? I'm going to hit start, and I believe I have everything covered up so that they can't see the code. So we don't want people crashing our Kahoot. We'll give it one more minute here. Any other last questions about the test before we get started? So good to see a TA in here. Thank you for swinging by, Josh. Mr. Mustache. That is too funny. How was my day? It's been a good day. It's been a good day. It's got to talk to Chelsea, so I'm really happy there. And so it's been a great day so far. Good start to the day. It's on, should find it on the usual place. And so the usual spot for our code, that's where we put it, the usual spot, where the instructors will tell you to go, where we've gone for every Kahoot code. That's the best hints and info I can give. If you know someone in the class, be like, where's the code? But make sure you're in our class, and yes. So let's see. We have 40 people. Is everyone ready to start the Kahoot? I think we can still get late joins. Are we ready to start the Kahoot? Let's see what the chat says. Should we wait a minute more or start? What do you say? Wait or start? Good. And we're only on a few second delay. I want to see something nowadays. Okay, so I want you, so we'll start here in 1 second. I want to see what the delay is. I think the delay we are getting these days is about 3 seconds. Now, here's some tips. Remember, don't put the code in the chat. Go to the usual spot where we do the Kahoots. Go to the usual spots where we do the Kahoot. We're going to do the, oh, I haven't snapped yet. I haven't snapped. You can't do the snap yet. Have snap written, so have snap typed out so you're not typing it. And there is a more chat delay, we think. So our usual site, so make sure, wait, I haven't typed snap yet. I haven't done a snap yet. You can't do that, or when I snap, it doesn't make sense. So we're going to do a snap right here. When you hear the snap, I want you to make sure, have snap written out. I want to see what the delay is. Here we go. 1, 1,000, 2, 1,000, 3, 1,000, 4. Okay, we're on about a 3.5 second delay, which is awesome. So if at any point you think you're lagging behind, click reload in the top. Please note, if you think you are lagging behind, reload the page. So just make sure you hit reload and make sure it's going live. So you want to try to be, because we've got like 30, 60-second questions. And remember, this is for fun. Remember to take more notes. But we're going to get started here. I'm going to hit the start on the Kahoot button. And if you hear a lot of background music, please tell me. I'll make sure we're not getting, like, we might have desktop audio. Just tell me if you're like, Brian, there's a lot of crazy audio. I'll fix that immediately. Okay, I'm hitting start. We're going to switch screens here. Let's get into this. I think we got it blocked. What is the missing value of the difference? Perfect. Okay, so we're looking at that difference right there. Ooh, this is a tough one to start. What is the missing value of the difference? So I'm going to give you hints while you're doing this. If you're saying, how in the world am I going to figure out that missing value of the difference when I only have the information that's on the screen? Well, think about this. Down or right over, I'll hover over it, you have a confidence interval. And the confidence interval actually has in the center of it y bar 1 minus y bar 2. So I'm literally giving some big hints. With that information, you can probably guess the answer right now. Because think about it. The difference is actually the center of the confidence interval. And then we'd have a margin of error, a plus or minus. So if you think about these two numbers averaged together, which it's basically 18 and 28. So 18 and 28, just 18 and 28 averaged together. And you can actually figure out the difference. Because the difference is the center of the confidence interval. I'm always going to be giving hints here because this value that you're missing right here is in the equations y bar 1 minus y bar 2 when you look at your equation sheet. Very important thing to know. And it would be these two numbers averaged together. Do you remember when we learned previously that if you take the two confidence parts, the upper and the lower, and you average them together, you will get the center of the interval. So the difference is the center of the interval. And the answer, if you haven't done it yet, is going to be this blue one, as long as I'm doing the math correctly in my head, because it's the average of the two values. So that was the answer, and you did a great job. Wow, so many people with the right answer right there. Please review this, and please ask questions if you have it. I'm going to give hints while you're doing the question. So if you don't know it immediately, don't worry about guessing. Focus in on what I'm saying, and maybe take notes on that output. If you notice, that was the 2 sample t output. So let's take a look at this. This is the two sample t output. You've got a lot of things we talked about yesterday where you could just put a mu right here, mu male minus mu female equals 0, and you've written the what. I want to see it in the chat. If you write mu male minus mu female equals 0, you've written out the what. Make sure you know what Brian just did a quick trick for right there. You've written out the null. Great job, Joe and Jackie. You guys know what's going on. If you do mu male minus mu female, you've written out the null hypothesis. And look what you have. You have two means, a mean for male and a mean for female, which means you are doing a two-sample t-test. And that's why we call it two samples. You have a mean for males, a mean for females, two samples, and you're comparing the means. Important to know what this output is when you see it. So let's continue on. Great job, amazing answers in the chat. And we are doing great today. Cheerful sloth, I love that. I've gotten to meet a sloth before. They're super cool, and I'm glad you're a happy sloth. Happy sloth is a good sloth. What is the missing t ratio? I love this question too. The missing t ratio is up there. So now you can see you did get that answer correct before, but how are we going to find the t ratio? Well, the t ratio mathematically is y bar 1 minus y bar 2 over the standard error of the difference. And wait, y bar 1 minus y bar 2. If you've already answered, I want you to tell people, if I'm doing y bar 1 minus y bar 2, I'm finding the what between the two sample means. Y bar 1 minus y bar 2 is the what between the two sample means. Y bar 1 minus y bar 2 is their difference. So that's what that is. That is y bar 1 minus y bar 2. It's the difference of the two sample means. And then the standard error of the difference, this is the formula. I'm going to slow down while I say it. Square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. I think I got it right, but that is the standard error of the difference. And if you look at the formula sheet, you will see all you have to do is take the difference and divide by the standard error of the difference. And if you notice, the numbers are kind of nice right here because you basically get negative 0.23 over 0.023. And one, don't forget that negative sign. And literally all you have to do to find this t ratio right here is divide these two numbers. Dividing these two numbers will get you the t ratio. So literally the answer, which you're about to see, it's gonna, there we go. Oh, I'm going off the screen, I'm disappearing. The answer is right there, and that is the ratio of the difference to the standard error, which gives us the t ratio. So if you knew that right there, that all we do is we divide the difference over the standard error, you're doing an amazing job. And remember, this is up for review, and ask those questions in the chat. If you notice, we're focusing a lot. Oh my gosh. Y bar 1 equals difference, that is correct. Y bar 1 minus y bar 2, sorry, I misspoke right there. Y bar 1 minus y bar 2 is the difference between the two sample means. That is literally this in this output. The upper confidence interval plus the lower confidence interval divided by half, that is the difference also because that's the center of the interval. And you can see that right here in the output that if you were to average these two numbers together, you would get this right here. Now you don't usually solve for the difference by doing that. You usually get the difference and then make a confidence interval. But if we're testing your knowledge, we might see if you know that averaging the confidence interval gets you the difference. Yes, this output is highly likely on the exam. And we've covered like a lot. It's in the chapter reviews and we've covered it in other reviews. This output is highly likely, and you'll notice I'm focusing in a lot on the output here because I know we do a lot of theory in the class, we do some output for the projects, and I want to make sure you understand all of this output that you could possibly see on the exam. So I want to make sure as test relevant as we could possibly get. Great question. Thank you, Michael, for the question in the chat. Ask all your questions at any time you have them, especially between questions. Great time to focus in on whatever you might be thinking. Equation to find the t ratio. Let me see here. Can I write that out quickly enough? Give me 2 seconds. Watch this. I think I can do it. Give me a half second here. I'll write that out at the end. The equation, it's on the formula sheet. It is y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. I'm a little afraid to bounce around between screens right now, but at the end, if you have additional questions, I'll write out all the formulas, and they are on the equation sheet, but I just don't want to leave the screen unless something crazy happens. We end the Kahoot or somehow reveal the code and get crashed. Some good questions. Stellar Crab, what happened to Sloth? Where you go, Sloth? Here we go, quiz time. Interpret the interval in context of the problem. Now this one you need to be saying out loud because I think click only the I did it ones and maybe click the blue one. I hope I said all these as right answers. Let's hope. So what do we have here? We have a confidence interval for the mean. And I want to see those answers in the chat. If you've already clicked that you did this, I want you to put your answer in the chat. Try it. Try writing your answer in the chat, or if you're watching this at home right now, try writing out your answer. So here is the standard interpretation. This is without anything in context. I am 95% or I am blank percent confident that the true blank is contained in the interval blank to blank. So people should be asking me, what is this for? Well, this is for the GPA of UT students. So that is what we're trying to make an interval for. I am 95% confident the true mean of GPA students is contained in the interval, and then we have to say the interval, 3.81736 to 3.849. Practice this in the chat right now. Make sure you know I am. I'm going to write it out here in the chat. I'm going to write the blanket statement. I am blank percent confident that the true blank, this is the hard one, is contained in the interval blank to blank. I am blank percent confident that the true blank is contained in the interval blank to blank. I am 95% confident that the true mean is contained in the interval. Make sure to say true mean of UT students' GPAs. Make sure to do that last part of the interpretation. Anna, great answer right there. And Alex and Jennifer, great answers. I am 95% confident that the true mean GPA of UT students is contained in the interval 3.82 to 3.85. And we'll probably be fine on how many decimals you use. We usually say 2 decimals on the test or 3. I think this one says 3. Amazing answers in the chat. Did I not mark that answer as correct? Did I not mark that answer as correct? Oh no. Oh no. It said wrong? Do you guys want to do something? Do you guys want to restart the Kahoot? Oh no. Can I fix that? Oh no, sorry guys, I was making adjustments to it. Restart, should we restart the Kahoot? Should we restart? Okay, vote in the chat, restart yes or no. Calzone Tyrone. Okay, here's what we're gonna do. We're gonna restart, and we're gonna keep the same order to the question. Okay, wait, we got a bunch of no's. Okay, we're not gonna restart. Remember, this is for fun. I'm sorry, I was making adjustments to this morning. Calzone's here. Calzone, we've still got the code. I think you can still join in late. So we're gonna keep it going, and here's what I'm gonna do. I'm going to download the results of this. And anyone who's in that, here's what I'm going to say. If you missed that, you can still win if you send me your place. If you're playing right now and you're the highest person who is in this wrong answer group, you can still win. So actually what you've done is you've probably increased your odds because you're in a special group. And if you are in this and you say, Brian, here's what I got, I will let you be a winner no matter what. So these other people, they're in their own little group, and so they have to actually win to win. Does that make sense? If you win and you're in that group, you win. So actually getting that wrong was kind of a bonus, but they're gonna have a better chance, these people. Does that make sense? Is that fair to everybody? If you got this answer wrong and you send me your result, and I can see whose results were what, so you could get 8th place right now and still win the Kahoot and still win the Starbucks gift card. Does that work for everybody? Is that nice and fair? Do we get some yeses in the chat for that? If you miss this question, and you're the highest person who missed this question, you still win. If this chat is silent. Okay, that works. Calzone likes it. I'll like that. I'm sorry, guys. I was making some changes this morning, and I forgot to click a button. First mess up on a Kahoot, so, whew. Okay, so let's continue on. Remember, please email me your spot. If you are the top winner who's still got this wrong, then do it, and we will say you got it. Okay, let's continue on here. And let's do it. Agile Dove is in the lucky group, probably, who got it right. Let's see. Luckily, that happened early on. I like it. Simple problems, simple solutions. What is your decision regarding the null? Look right here. This one is pretty easy. We've only got 2 choices when it comes to the null. Calzone, fan favorite right here. My email is just bs@utk or bstevens@utk. We only have 2 choices, reject or fail to reject the null. So I'm giving away some answers. So the only options, we can't do either of these. These are nonsense. Don't choose these. Don't choose these. It's gonna hurt if we see that right there. It's gonna hurt if we see that in the chat, or not in the chat, but in the answers. When do we reject the null? We reject the null when the p-value is what? When the p-value is this, reject the null. When the p-value is what? I want to see it in the chat. So when the p-value is this, reject the null. Make sure to be taking notes. When the p-value is low, reject the null. And what do we mean low? We generally mean below 0.05, which is our alpha level for most tests. Look at the p-value right there. The Pearson, the one right there, has your p-value. And is that lower than alpha? No, we fail to reject the null. So once again, and great job, if the p-value is high, just let it fly. Ben, you know what's going on. No, it's all right, it's all right. That's me too, Michael, that's me every day. So if you're wondering how we did this one, and please ask those questions in the chat, it's this p-value right here. We like to say that Pearson has your p-value. I know these p-values are basically identical, which means if you did do the other test, the likelihood ratio test, you would still fail to reject the null. So we either reject the null when it's below, the p-value is below alpha, and you can tell this is p-value because you see prob. If you go back and rewind and look at the other output, you will see prob greater than t and stuff like that. So that's the p-value of a result, or the probability of result as extreme or more extreme than our result happening by random chance, given that the null is true. That's what a p-value means. And this p-value right here is above 0.05, which is our general alpha unless otherwise specified. Someone can change alpha. We don't do that much on the test, but alpha is just the point at which you reject, and we'll talk more about alpha later on throughout this. Does that make sense right here on what we have going on with p-values, and this being the p-value, it's above 0.05, so we fail to reject. The only two options on the null are reject the null, thus you have evidence for the alternative, fail to reject the null, you do not have evidence for the alternative. And those are the two things again. You either reject the null, if this was below 0.05, general alpha, thus you have evidence for the alternative, or you fail to reject the null and do not have evidence for the alternative because you're going to kind of retain the null, we sometimes say in statistics. So great stuff right there, good review. Let's do another question. Quiz time. If someone wanted to write a null using this data, which of these could they use? I think I've already given this one away. Oh no, this one's not been given away. This one, I love it. What do we have going on right here? Well, one of these is very illogical, and it's the one in red. The one in red is illogical. It doesn't mean the one in yellow is right. The one in yellow is not right either. But the one in red is illogical because that's not a proportion. Proportions are numbers contained between 0 and 1. So when you write out a null using the proportion, you have to have something like p equals like the yellow one. But the yellow one's not the answer. Hint, hint, it's not the answer. So the yellow one is a correctly written test for the null for the proportion. And then the green one, which is also not the right answer, is two sample means. And we don't usually test a difference of 3.8. You could technically test that. Usually we test a difference of 0 to see if there is a difference, and the null would be that there is not a difference, so we'd say the difference is equal to 0. So this might be proper if we were testing two means, and everyone got the answer right. I eliminated 2, but the correct answer was this right here because we are testing one mean. How do you know this? Well, you just see the mean. We're testing the mean, so this could be a possible null. And the value we're testing can be anything. I can say, is the GPA of UT students equal to 4.0? And then that would become mu naught. Very important to note that if you're doing notation, this value right here that I am hovering over is mu naught. Mu naught is the hypothesized mean. What is this 0.38 right here? This 0.38 I'm hovering over, who can tell me in the chat, in notation, what is that 0.38? Like what is 0.38 when we do p equals 0.38? Like if we did have a question that said, we want to see if the proportion is equal to 0.38. What would that be if we were testing 0.38 as a proportion? And look at the similarities we're about to hear. Over here, this is mu equals mu naught when we use the notation for 3.8 being mu naught. And down here, if we're doing 0.38 and we're testing p, then this has to be, what would it be? Say it in the chat. Who's got it in the chat? Oh, I'll give it away in a moment here, but I love seeing the answers in the chat. Think of it, I'll say it again. P naught, you're exactly right, Jessica. Thank you, Jessica. We would be testing P equal to P naught, and we're testing mu equal to mu naught. And that's because this is the hypothesized mean, and this down here would be the hypothesized proportion. Important to know your notation and how to use it, that we're always testing against some value. And when you test two means, the value we test is 0. Don't worry, warrior. We're here to help you review and ask questions if you got them in the chat. We're glad to have you. So let's continue on. This is our good time to review right here. Swift Tiger running fastly into the lead. Let's take a look. Find the missing value. What missing value would we go for? Oh my gosh, we have an expected value. Okay, so we've got our formula sheet. As soon as I see stuff like this, I'm gonna do this on the test. I'm gonna look here and I'm gonna go, okay, that's the count, which are the observed. So that means that's an observed value, that's an observed. There were 163 females who said no to being born in Tennessee. There were 128 males who said no. Okay, cool, those are expected, counts, excuse me. Now we're gonna go to the expected values. So with the expected values right here, these are expected values. That's fine. We're here to help teach stats. That's what we do online. And so we're going to do some multiplication, which everyone can do. So to do the multiplication, we need to know the formula to get this expected value. And I wish I could draw on this right now. Watch my other videos where I draw on it. It's simply the row total, I'm circling it, times the column total over the grand total. Row total times column total over grand total. That's the formula you should be solving right now. 421 times 479, look how they connect in on it. 479 connects in on this cell, and 421 connects in on this cell, and then you take that total and divide it by the grand total. If you want to check out, sure, we'll show the answer in the chat. Let's show that answer in the chat. We can show those answers. If it's really close to the end, mods, feel free to show the answers. Yes, I am a teacher. I teach here at UT. That's where we do our education. And so right here we have row total times column total over grand total. I think the answer, oh wait, yes, Megan, there is a typo in that. If you want to retract that message, and then we see the answer too in the chat, and we should have the right answer. Woo, we got the right answer. Amazing work. Now I want to point something out. If you are practicing these problems, I'd like you to do this. Think about this. You can use this output to check to see if you have the other answers correct. You can literally do the equations by doing this right here. Megan, I am going to make you a mod, then you will not have to worry about that. Let's make user mod. Megan, you should be a mod. Cool. So we see right here that we do row total times column total over grand total. This value right here, 159, should be 421 times 291 over 770. Oh, the answer should be red and green. That's awesome. Annie, you gave a really good kind of cheat right there, and I say that in a good way. You gave a really good cheat that you can just use the expecteds to figure it out, because the expecteds must add up to 421. So you know what I would do on the test? I would solve it both ways. That's my tip right there. Annie's giving the extra bonus way of doing it, so you can just subtract, but it could be a bigger table, so there might be more numbers to subtract, but make sure maybe that the totals of the expecteds add up to this. That's a secondary way of solving it, and if you solve something two ways and get the same answer, you're probably doing it correct. It's like a double check. So great stuff right there. Let's continue on. And remember, ask those questions if you got it. That's how I check to make sure I'm right. You got it. Do it. That is amazing. Thank you guys. Let's get some amazing grades on this test. Okay, next question. Let's do it. Which of the following must be met for all quantitative data, tests, and intervals? So you'll see later on we do have that random 10%, but then we have some additional stuff. The code is in our usual spot, Warrior. If you're part of the class, you'll know where to go. And so which must be met for all quantitative data? Well, let's think about this. We have count data. Count data is when two variables are categorical, but wait a minute. So you have to have like gender and you have to have pet preference. That would be count data because it's two categorical variables. That's totally not like quantitative data. We have expected cell count, which we'll hear more about later. Expected cell count is you need at least 5 expected cell counts, which is for the chi-squared test. Then we have success failure, which means we need at least 10 successes, at least 10 failures, found by NP naught NP naught is greater than or equal to 10, NQ naught is greater than or equal to 10. And with that right there, we would be able to eliminate and figure out that the nearly normal right here next to me, nearly normal is it. Great job. What does nearly normal mean? It means that the distribution of the mean will be nearly normal. Now here's the biggest thing. We can do this a lot of ways, and I could probably review this topic right here for about 10-15 minutes. Don't stress out about this too much. 1, know the condition. 2, have a good understanding of how it works. If the distribution of your parent population, which is the original distribution, is normal, it's no big deal. Then the distribution of the mean will be nearly normal. But if there's some skew, depends on how much skew, then we do need a larger sample size generally, and that's where we get into the large enough way of doing nearly normal. Nearly normal is the condition, but then via large enough, we can meet the nearly normal condition. There are other ways too to show that it's normal. We could do a normal quantile plot, and we could do a goodness of fit test. If the normal quantile plot is straight, then it's nearly normal. If the goodness of fit test gets a p-value above 0.05, then the original distribution is also normal. Like I said, this question we should understand what the condition is. It can usually be about 2 to 5 points on the test. Usually it's closer to like 2 or 3 points, but it's a very kind of smaller condition. But it is used when we do 1 sample means tests and 2 sample means tests. So this is a condition that is used for quantitative data because the distribution of the mean needs to be nearly normal. If you have questions on that, make sure to ask. And definitely I covered more in depth in other videos, but it's kind of one of those kind of important topics, but I don't want to spend 20 minutes going over it because it is one of those tricky ones I know students have had a lot of trouble with, and so please review it, but don't spend like 2 hours reviewing it. Spend like 5 minutes being like, okay, how do we meet the nearly normal condition, and have good notes to understand when we use the condition. We use the condition when we have quantitative data, the 1 sample means test or the 2 sample means test, and when do we meet the condition? Well, generally we'll look at the shape of the distribution, and if the distribution is normal, then the distribution of mean will be normal, and if the distribution is skewed, generally a higher sample size will lead through the central limit theorem to be normal. The distribution of the mean will be normal. Any questions, feel free to ask. That is a tougher concept, and a little kind of quick review was done right there. Know when to use the condition and know what the condition means is my big advice right there. Swift Tiger still in the lead. Quiz time, interpret the difference. This might be one you say out loud, or I might have some answers to like not block. Oh gosh, I'm getting out of the way here. I'm over here on the side. You can't see me anymore. But we have right here, what is it? What are we doing? Is this a proportion difference? Or what is this? Think about what is going on right here and look at the answers. Well, if you remember from earlier, I'm just going to hop in here to the side. Is there an answer I can block? Okay, wait. The mean for, okay, let me see. Oh no, if I stand in there, I think I'll block one of the, oh, wait, no, I'm not blocking any of the real answers. I'll come in here now. I'm not blocking any of the real answers. Good. So I'm not blocking any of the answers you should care about. That eliminates 2 answers. So, but also I said this is not proportions. Remember that this difference right here is, when you look at this value, let's make it clear. This value you're observing right here is the difference between these 2 means. So since, oh no, it's all right. Since this difference is negative, so on this one, sure, I'm gonna go over it really in depth right here, and the answer, yep, good. So right here, what are we doing? I want you to think about my brother and me. If we did Brian minus Darren. Now Darren is older than me. Darren is 40 and I am 20, sure. I'm 37. And so right here we would do Brian's age minus Darren's age. You're getting it, you see it, because of the negative sign, which one's bigger? Now I know this isn't Brian minus Darren, but which of the means is bigger, like which mean was observed to be higher if the difference is negative? If the difference is negative, which of these 2 values is the larger value? Like when you subtract this from this, if the difference is negative, would the first number be bigger or the second number be bigger? Like when I do Brian minus Darren, Darren's older, so when we do Brian minus Darren, the second one would be larger. So female has a higher mean than male. So this means that the mean for females was this much higher than the mean for males. Darren's a cool guy too. He let me give the best man speech at his wedding, so he's super nice. So how did you know it's not mean? How mean and not proportion? Great question. This is a t-test. And I like to say Mr. T is mean. I'm sure he's a super nice guy. But we say the t-test is for the mean. So Mr. T, mean, because the t distribution is used for means. So this is doing a difference between the means. Great question right there, Joe. Thank you for asking that. This is the difference between the means because it is a t-test. And anytime you see a t-test, we are testing the means. If it was positive, would females be lower? That is very correct. That would mean that males was higher. If you do Darren minus Brian, it'd be 40 minus 37, and then you'd get positive 3. We're just putting in fake numbers here to kind of understand that if the difference is positive, it would be Darren minus Brian, which is 40 minus 37. We don't give out the code in the chat, but you're free to ask questions related to stats. Warrior, ask any of those stats questions. The chat, we don't put the code out there so we don't get Kahoot spammed. But feel free to ask those stat questions at any time. We get a bunch of visitors and we like it. So I think that covers this output really well. Make sure to notice that this is basically 48 divided by 16, or negative 48 technically, which is about 3. We did that one earlier, finding that t. If you average together these 2 numbers, it's like 15 and 75. That would average out to about this right here. It's 15 and 80 more technically. But the average of these 2 numbers is the difference right there. All these little things that we've been covering on how to read this output. You might see some important stuff going on right over here for later on. Continuing on to that next question. Swift Tiger, Space Crane is back in the game. Hopefully I didn't get them with that question earlier on. Which of the following must be met for all confidence intervals and tests? I'll say, so we got some answers right here. This is where, so we should see people answering. I'm not going to give it away yet. I like to do some stuff. And hopefully I clicked both answers. Encouraging people to say the code. Emily, amazing answer. We don't want people saying the code. We don't want to encourage people to say the code. So that way we want to make sure that the code doesn't get out there and we don't get a crashed Kahoot, because that's no fun. And then we can't review, and that's no fun. So in my class, I like to say something. You guys know what I'm about to say. Condition 1. You should be able to join. Go get the code from our site. You might be able to join. Try to join in if you can get the code from the site. Condition 1, and you should say random. Condition 2, 10%. Oh, they're saying in the chat. Condition 1, random. Condition 2, 10%. And so we have right here the conditions on what we're trying to cover. And the thing we do after that, Alex, amazing answer in the chat. Pause. Slow down your mind. These are the two conditions. Oh, Alex, you got your wish. We achieved Christmas. So I believe the odds of this, 1 in 4 chance. No, I'm not going to do the mathematics. It wouldn't be that hard to do. So, but we get right here that we have our red and green, really cool pattern right there. And please remember to play Christmas Unlocked. I like that right there. We have right here our 2 conditions that must be met. Randomness means, or random, you can just call it random or randomness. It means that you randomly take your observations. If I wanted to figure out if my students are doing well, I couldn't just talk to the students who want to talk to me. I couldn't say, it's not really a good survey. I mean, I know we did do that. We talked to the students who want to talk to us about the class, but that wouldn't be a comprehensive review. But think about, the T and Voice survey that you just did. The T and Voice survey would be, a view into all the students. So if you can get all the students and do a census of all the students, we're not covering that on this test, but you would get a good view. There would not be any bias, because then you would understand how all students felt on the class. You'd actually have the parameter. You would understand what % of students liked the class or didn't like the class. If you only get like 20% of the students to respond, which would technically cause some issues with statistics, you would just have sample statistics based on the class, but then you do have response bias and stuff like that. Let's not mention those. These conditions right here, success failure, is for what kind of data? I want to see it in the chat. When do you know when to use success failure? I want to see it in the chat, then I'm going to start giving questions off. There's like 26 in this, and the test is of usual length. It's categorical data. Feed those cats. We'll do it. Definitely take care of your animals. Success failure is for categorical data, such as like, do you own a cat? That's categorical data. And then we see over there nearly normal on the far side. I'll go off the screen if I go point to it. I'm disappearing just into the void. But we see over there on the far side nearly normal, and that is for quantitative data. So the nearly normal is for quantitative data, such as like, how old are you? How much do you weigh? How tall are you? Those are all quantitative questions. Be careful though, age group. Age group is categorical. That puts people into categories like, what age group are you in? How old are you is quantitative, but what age group are you in is categorical. And if I do misspeak, please tell me. I thought I was about to say something wrong, but I didn't. And so let's give this a shot right here. Let's go on to the next question. Swift Tiger, you are destroying it. Amazing job. Let's check out, we got another quiz question right here. Find that missing value. Is it for p-values? Drop a like. Yeah, drop a like. Oh, we've got a chi-squared, a cell chi-squared. I love these. Okay, so how do we get the cell chi-squared? Well, it is the observed minus the expected squared over expected. Write down that formula right now and try to solve this. Observed minus expected squared, and that's whole thing squared. So it's observed minus expected quantity squared of that over expected. Observed minus expected squared over expected. So you need to know what the observed is, and you're like, wait, Brian, there is no observed in this output. Observed is the count. The count is how many we observe, and the expected is found via the formula row total times column total of grand total. We're not doing that problem right now. So all we need to do, Anna, thank you very much in the chat. We have here 128 over 131.895. And you think about that, that's a difference of about 4. You can actually just find their difference because we are squaring it. So if you want to get technical, it doesn't matter which way you subtract, you're just going to square that difference. So 4 squared is 16, a little less than 16, 15. We're then going to divide by the expected. 131.895. So it's going to be about 15, and there will be this formula on the test. You will get the formula for the cell chi-squareds, and then also you should know the sum of all the cell chi-squareds. Megan, thank you for that answer in the chat. Be practicing these, be writing these down, know how to solve these formulas, and I'm trying to think what the right answer is. I think the right answer, don't quote me on this, I'm doing it in my head, I think the right answer is the green one. Did everyone else get that? I'm doing it in my head. If I got it wrong, it's because I did it in my head. Did I get it right? Yes, we got it right. I saw some clicks going away there at the last second. I was getting afraid. I was like, I'm doing it in my head. I'm doing it in my head. But I got about 15 over like 132, and I was like, okay, then it can't be about 14. It's got to be about this, and it can't be that. So we did get it correct. Make sure you can solve it. On a multiple choice, I could have gotten it, but if I had to solve, I mean, I could do a long division on that, but I don't want to. I just punch it in the calculator. I do, and here's one thing you might wonder. Here's a trick I do, and this is a suggestion for life, literally. If you ever have to solve a math problem, which is often school related, solve it in your head. One, that just gives you practice, and two, if you solve it on paper or if you solve it with the calculator and you get something drastically different, well, one, you either did it wrong in your head, or two, Brian's greater than jump, I like that right there. Or two, you did something wrong on the calculator. You either did it wrong in your head or the calculator. But if your answers converge, then you're doing it correctly. And as you do more and more problems, you get more and more used to doing a mental solve in your head, and you build up tricks. And I just like it. I figure it's a game. I like seeing that I got it right. I'm like, yeah, I did it. So if you're like me, then try giving it a mental solve first. But don't, on the test, bring your calculator. One time I didn't bring a calculator to a test, and I didn't do that well because I was like, I'll just do it all in my head. Learned my lesson very quickly. So calculators are a huge help and save a lot of time, but we are prone to misenter stuff. So, thank you guys. You guys are awesome. I appreciate it in the chat. So let's continue on here. Swift Tiger, doing amazing right there. Let's take a look right here. What is the alternative hypothesis for the two-sided test? I'm going to hop out of the way. Oh, we don't got to hop out of the way. So, okay, so the null has the what? We can eliminate one answer right here. This is a two-sided test or a two-tailed test. We should know it pretty quickly. We can eliminate. I might be able to get him in here. Do you want? We'll get him in a second here. I'll see if I can get him. He might be watching the chat. Oh no! So here's what we should know for this. We should know that the null always has the what sign. The null always has the what sign. How'd you know it's a two-tailed test? Just, we said it. This question is saying, like, if you're doing a two-tailed test, which one would it be? The null always has the equal sign. That is true. And then think about this. The greater than, am I pointing to the greater than side? I think I am. The greater than test points this way, so that's the greater than test. The less than test points this way. We're going to look over this output here in a little bit and talk about this. But the greater than and the less than test point to the left and to the right, so they shade to the left and the right. People were asking in Stat Lab, and it was a great question, why is it called a two-sided test or a two-tailed test? It's because it shades both sides. Now this is different than a two-sample T. A two-sample T has two means. We call it a two-sample T because it has two means. We call it a two-sided test or two-tailed test because it shades both sides. And the two-tailed test is the does not equal sign. Look at how the does not equal sign points both ways. You can see that right here. Where is it at? There it is. You can see right there that that does not equal sign points both ways, meaning we're going to shade both sides, two-tailed test. Great job on that answer. I want to point something out in this output right here, that this right here is the alternative for the does not equals. If you notice, it would be the shading right there and the shading right there. You can't really see it, but there is a little bit of shading over here, and there is shading right there. How much area is below that red line? How much area is below that red line? Does anyone know? Like if I were to shade to the left of this, how much would be below it? Like how much, like to the decimal, to the fourth decimal? How much would be below that? You are exactly right, Jennifer. It is 0.0021 because that is the less than test. And that means here's where your T is at. Your T is at a negative 2.879. That is where this is at. That's the T-score. Now the difference is negative 0.04. And you notice that's negative 0.047. That's where the difference is. And then as a T-score, which is the difference standardized, you'd be at negative 2.8. Now I know that we say if you can get 1 minus it to get above, which you see, and I just clicked in a random spot. And right here, you can see that this is not quite double. That's due to decimals in the background. You'll see that on a p-value test coming up later on. But if this was blanked out on the test, hint for a question coming up, this would be 0.0042. But there's decimals that are just rounded up and rounded down for these. Like this might be 0.00206 and then it rounds up, but then when you double it, it's 0.00412 and it would round down. It's just rounding differences. So don't worry. I know that the two-sided is double the one-sided, but it's just rounding differences. Let's see some questions that cover that material. Swift Tiger in the lead right there. We'll have some people drop their places in the chat. Say your conclusion of the test out loud. I want you to be saying this. I want you to wake up your neighbors. Oh my gosh. Maybe click the green one this time. Maybe click the green one. Let's all bet on green. Okay, so what do we do here? Are we going to reject the null or fail to reject the null? Here's where we practice. When the p-value is low, I reject the null. When the p-value is high, I just let it fly. What do I mean by let it fly? I'm not going to reject it. There's no good rhyme I could make up where I say when the p-value is low, reject the null. When the p-value is high, don't reject the null. It's better to say when the p-value is low, reject the null. When the p-value is high, just let it fly, because that rhymes with high. You got better rhymes? Give me some better rhymes. And you got it. You are rejecting that null, but I want to hear it in context. Here's the problem on this question we haven't done yet. We need to know the null and the alternative. Not clicking blue. Don't click the blue. I'm scared of that blue button right there. Don't click that button right over there. And don't click the red either. If you didn't do it, you don't get the points. So we see right here that we need to know the null and the alternative. Now here's the trick. The trick is going between these. Weston, you're awesome. You got to say gender is independent of broken bone. Gender is not independent of broken bone. Oh, we got all those right answers. We got it. Oh, and I did it correctly. Woo! You lived on the edge and you won. So if you notice I'm doing the null and the alternative, please note this trick. Gender is independent of breaking a bone. Does everyone try writing the null right out? I think I have a question coming up where you have to write the null and the alternative for this, but you should know, just seeing this output, that breaking a bone is, and that'd be the alternative. Kate, you are right. The alternative is breaking a bone is not independent of gender. And the null can be, and you can use X and Y kind of interchangeably. I like to say X first. We should be all right on the test if you flip them, but I usually go to the X. Gender is independent of breaking a bone. Gender is not independent of breaking a bone. I reject the null that gender is independent of breaking a bone. I have evidence that gender, and I could say, is associated with breaking a bone. And then maybe a test question might say, who was more likely to break a bone, males or females? So we have sufficient evidence that there's association between break. Peyton, amazing answer. That's like one of those A+ answers on the test right there. Great job. We have sufficient evidence due to the low p-value. The low p-value tells us that the differences we are seeing up there are unlikely due to random chance. How would we expect that to look if the null was true? It'd be closer. Now don't just look at that and say, oh, it's kind of close, the null must be true. No, look at the p-value. The p-value is the probability of your results or results from our stream happening by random chance variation given that the null is true. You don't need to know that. It's a little too in-depth sometimes. It's not bad to know, but how can you tell whether it's independent or dependent by looking at the mosaic plot? The closer the mosaic plot is together, then the more independent it is. Because if males and females broke bones at the same amount, like if it was perfectly flat across there and you saw the same amount of males breaking bones as the same amount of females, then it would be independent. Like, well, I guess about 52% of people break bones, or maybe 48% of people break bones. So it's kind of independent of whether you're male or female. Like, it doesn't give you additional information to know someone is male, but in this one, which does have some dependency, we see that knowing someone's gender, and this is a good way to understand it, gives you information about them breaking bones. If you know someone is male, then you know they're more likely to have broken a bone. And the answer is we use the Pearson. Matthew, here's the trick to remember that. The Pearson has your p-value. Just make sure to maybe write that down, that the Pearson has your p-value. And the reason we use it is because the Pearson chi-squared test statistic is found by the sum of all the cell chi-squared test statistics, or the cell chi-squareds. Those are not test statistics, those are just cell chi-squareds. So this value right here would be the sum of all the cell chi-squareds, thus we're going to use this p-value. Now they are the same. Chi-squared null is that the variables are independent. Joe, that is correct. Gender is independent of breaking a bone, and then the alternative would be gender is not independent of breaking a bone. Do we have to include the p-value in the alpha level in the answer? Sometimes we have you do that. We might say, usually we like to break apart the answers. We might say, what is your conclusion? And then if we want you to include the alpha level, we do say, include your alpha level in this conclusion. Kind of the big answer, which would be this would be maybe a 5-point question. I'm gonna slow down a little bit here, and feel free to say slow down. The 5-point question would be something like, give your conclusion in context of the problem, mention your alpha level. Now that's a hard question, that's a lot of parts. So usually we try not to put that many parts in a question. But if we did write a question like that, I would say at the 0.05 alpha level, I reject the null hypothesis that gender is independent of breaking a bone with a p-value less than 0.0001. I have evidence that there is an association between someone's gender and breaking a bone. It looks to me that males are more likely to break bones than females. That is a huge answer right there. Usually we don't put it to that many parts. I can see how that would be a harder question, but that kind of encompasses maybe 3 or 4 concepts. So usually we like to split the concepts apart, and we might say, do you reject the null? And the answer would be yes. And we might say, why do you reject the null? And the answer would be my p-value of less than 0.001 is less than alpha of 0.05. And then we might say state your conclusion in context of the problem. And you could say, I reject the null that gender is independent of breaking a bone. I have sufficient evidence that there's an association between gender and breaking a bone. And association does mean that they're not independent. You can say that they are not independent, but look, notice how writing our null alternative helps us with this. Any additional questions on this? I know I did a huge review of chi-squared right here and how to interpret the results. And that's some things those are some of the things people wanted at the start of this review. So I hope that helps out with understanding it. Is the alpha arbitrary by the statistician? Kind of. 0.05 is the most commonly used alpha. It is kind of playing games if you change your alpha level. You don't really want to see people playing with alpha. In stricter research, people might lower their alpha to lower their probability of a type 1 error, because alpha is your type 1 error. It's the percent of the time you reject the null due to random chance when the null is true. It's your type 1 error probability. So a statistician, a good statistician, if they're doing like medical research or something, might lower their alpha, being more careful not to make a type 1 error. Yeah, and I will say this, assume 0.05 unless otherwise stated. In scientific research and across all statistics, 0.05 is general alpha. It's what is used in pretty much everything. But you can change your alpha, and you can say with an alpha equal to this, and that's that little Jesus fish, little swirl fish right there. So if you know what I'm talking about, but that is your general alpha right there. So I think, can anyone put an alpha in the chat? I'm trying to draw it out and I'm like, it doesn't look good, but I think people know what I'm talking about. So let's continue on. Swift Tiger in the lead. And let's continue on. Story time, what is the type 1 error? Okay, I gotta say this story time correctly. You're walking in the woods. Now think about all this stuff right here. Now don't click any of these answers. You'll get it wrong probably if you randomly click an answer. So you're walking in the woods, and you see what looks to be a stick. Now, what do you think is the null hypothesis for seeing something that looks to be a stick? Do you think it's a stick or it's a snake? What do you think is a good null hypothesis? Should you think everything in the woods is a stick or a snake? I'd probably say the null should be stick and the alternative should be snake. So you need evidence something is a snake. And what do we mean by evidence? Maybe it moves. So if something moves that looks like a stick, does that mean it's a snake? Well, I mean, maybe. But think, things hit on the ground, things move around, animals move around. Maybe it was something that ran underneath it. Maybe the stick got hit by the wind. So maybe it's still a stick. What if you hear it hiss? Well, maybe some wind blew through it in a weird way. What if you see it open its mouth? Okay, then it's a snake, that's a snake, that's a snake, that's a snake. Sticks don't do that. So what do we have here? What is a type 1 error? So you gotta do this, you ready? In a type 1, you guys have seen me do this and hopefully you know how to do it too. The null is true. In a type 1, it's a magical stick. In a type 1, the null is true. I want you to look at that null right now. The null is that it's a stick. Look at the chat and look at that null and say, it is a stick. Now, in a type 1, the null is true and we reject it. In a type 1, I'm holding up 1 right here, and here I'm making a T to say in a type 1, the null is true. So it is true that it is a stick. But wait a minute, we're going to reject that and say we have evidence it's a snake. So you should have your answer. In a type 1, it is a stick because the null is true. And in type 2, in type 1, it is true that it is a stick, but we reject it and think that's a snake. I'm not going to say anything else because I don't want to mess it up. It's so easy to reverse these. So the answer should be, it is a stick, and we think it's a snake. You think it is a snake, but it is not. Did I get it correct? Woo! I'm always right there, And so we're going to practice type 2. That might be the next question. Do not want to have me type an error with my eyes are horrible. You should see it, Ryan. I've got like the screen. Literally, I can reach out and touch the screen. It's that close to me, which I've been doing my whole life. Like if you come to office hours, I'm like, bring the screen closer because I'm really blind, and I'll just look at it like this because I'm really blind. So I got you right there covered. But that is practice. And if you notice, we have a lot of reversals on it. Even practice type 1, type 2. When we get to the type 2 here in a moment, I want you to know the trick for type 2. In a type 2, the null is what? Do you see the 2? In a type 2, the null is what? In a type 2, the null is what? In a type 2, the null is, I want to see it in the chat. I want to see it in the chat. In a type 2, the null, it's one I wrote, but I want to see it. Type 2, the null is false. You are right, Jessica. And then we're going to say the second F. In a type 2, the null is false, and we're going to fail to reject it. So let's do the tree question. I think that should be next. Here we go on the tree question for a type 2 error. Is it? Nope, they're mixed up. It'll be coming later. What is the p-value for this test? Oh, cool. Yeah, I like this one. So we should remember this one from earlier, and we should know the trick when looking at this. If we look at this output, the Pearson has your p-value. Oh my gosh. I'm glad you stepped over it and it didn't get you, Megan. That's, oh my gosh. Copperhead. I saw a baby copperhead one time. I was like, what is that? I was like, oh, it's a baby copperhead. So scary, scary. I'm less scared of snakes. I'm more scared of spiders. You don't see spiders. You just like, when you see them, they're like on you. That's when you see a spider. So the trick for this one is the Pearson has your p-value. So when you're looking at the chi-squared output, this is your sum of all your cell chi-squareds. And the Pearson, oh no, and the Pearson has it. What is the likelihood ratio for then? That is a different type of test. It's done very similarly. It's just jump displays all the output. So at least for our class right now, just skip over it. It's just another way of doing it. Here's a lot of statisticians have made many different ways to do very similar tests. You've got pooled variance problems, you've got likelihood ratios, you've got Pearson's chi-squared test statistic. So it's another way of basically doing the same test. So in truth, it wouldn't be a horrible idea to use this, but the reason we're using this one right here is because that chi-squared, which I know they're both the same in this problem, which they're oftentimes kind of close-ish, but they are different tests for a reason. They do come to different results sometimes. This Pearson value right here, which in this test was the same, but it's not always, is the sum of all the cell chi-squareds. So if you took all your cell chi-squareds and added them up, you would get the Pearson chi-squared test statistic. I'm going to do a reverse problem right here, and I'm going to ask you guys, what was the matrix we used to solve this? This was a what by what question. So think about this. What was the was this a three-level question like, do you own a cat, dog, or neither, and gender? So that'd be like 3-level, 2-level question. Maybe it was like class level, which is 4 levels, and then maybe it's like your favorite restaurant with 4 levels. This was a 2x2 Western. You got it right because the degrees of freedom are 1. So seeing the degrees of freedom are 1, you know the only way to get that is 2 times 2, reduce it down to 1 times 1. I think we have a degrees of freedom problem coming up, but this was a 2x2 like, were you born in Tennessee and have you broken a bone, would lead to degrees of freedom 1 because there's 2 levels to born in Tennessee and 2 levels to broken a bone. The formula is rows minus 1 times columns minus 1. That turns into a 1 by 1. So that was a reverse question on degrees of freedom to see if you knew how to solve it. Great job in the chat. Okay, Swift Tiger destroying it. What is the equation for degrees of freedom? Great topic right here. I gave this one away. I've got 90 seconds. It's way too long. So you should know degrees of freedom for the chi-squared test of independence is rows minus 1 times columns minus 1. So when we look at this right here, we know we're doing the chi-squared. We know we can write the null and alternative for this being gender is independent of breaking a bone, gender is not independent of breaking a bone. We also know how to do the trick to figure out the degrees of freedom. We know that trick right there. We also know that the chi-squared Pearson is the sum of all the cell chi-squareds. This time we do see a difference, but this is the chi-squared test statistic, the sum of all the cell chi-squareds, and this is the p-value, which tells us we reject the null because the p-value is below 0.05. Really good review of this output, knowing everything you're seeing right here, all the important things. We're not going to do the likelihood, we're not going to do, or the log likelihood, we're not going to do the r squared for this, but good to see you here, Cruel. I am a teacher and glad to have you. Ask questions if you got them. The equation is 1 by 1. Let's make sure you see it. The reason the equation is 1 times 1 is because there are 2 rows and 2 columns. With 2 rows and 2 columns, what do you do to it? You do rows minus 1 times columns minus 1. Rows minus 1 times columns minus 1. And that will give us 1 times 1. And in other words, and does everyone see the answer right there? Is 1. There is 1 degree of freedom because it is 2 by 2, but then you reduce it by 1 on each side. So all that great stuff right there. Keep it up. Great work. Ask those questions if you got it on anything related to it. And if people come in, especially if they ask real questions, we'll keep them in here. If they ask like, what's the code, we'll not. So next, let's see here. When doing a hypothesis test on the mean, which is a condition that must be met? Did I already do this one? It's a repeat question. Oh, you're fine. When doing a hypothesis test on the mean, which is a condition that must be met? And so I think, did I put a question here twice? I guess I did. It's for a single mean. I think you guys should get this. Remember, condition 1 is random, condition 2 is 10%. Then you need to pause, and we say we're doing on the mean. So it's about the distribution of the mean. We want the distribution of the mean to look a certain way. We want the distribution of the mean to look a certain way. And how do we want it to look? How do we want it to look? That means not the original distribution, but the distribution of the mean should look this. And we've done this one a lot. That's why I'm like, I don't have much more to say. Success failure is for proportions. The other two on the far side, way over there off the screen, are for the chi-squared test of independence, the expected cell count, and the count data are for the chi-squared test of independence. So the answer is nearly normal. Nearly normal is when we're dealing with quantitative data, either one mean or two means. Good stuff right there. Swift Tiger, you are doing amazing. Let's see what we got. What is the null for this test? I think we're going to do a chi-squared here, and I think I've given this one away. I got to get out of the way. I got to see the mean. I can block these two answers. These are wrong answers. So I've got 90 seconds on the clock, a lot of time to talk about this one. We've talked about this output so much. Please remember the trick right here. This one you can get like that. This is the only test. Take a note right now. I'm trying to draw up some big notes for the test. This is the only time you will not use statistical notation. The only time you do not use statistical notation is when writing this one out. If you notice the other nulls we've done where things like mu equals to some value or p equals to some value or mu1 minus mu2 equals 0, if you're taking notes, p equals some value is for the proportion. Mu equals some value is for testing the mean. Mu1 minus mu2 equals 0 is for testing the difference between two means. Mu1 minus mu2 equals 0 is the null that there is no difference. So now the fourth one we did was the chi-squared test of independence. The chi-squared test of independence, we simply write the word independent between the two words. Gender is independent of breaking a bone. And we've got the null. To do the alternative, we simply do gender is not independent of breaking a bone. I still understand when using independent, non-independent, or equals or does not equals. The only test we do the independent stuff for is for this one right here. So if you see this output and both variables are categorical, so Nicole, great question right there. It's when you have two categorical variables like gender and breaking a bone. Gender is categories, breaking a bone is categories. And so when you see that, you should realize, okay, this is the chi-squared test of independence. And I'm going to ask a question in the chat. By both these variables being categorical, what condition do I meet? Since both variables are categorical, I have met what condition for this? Since both variables are categorical, I meet the what data condition? It's I call it the fourth condition sometimes. What condition? Both variables are categorical. Count data condition, Jackie, you are right. Amazing answer in the chat right there. It is the count data condition by both variables being categorical, and that means we're doing the chi-squared test of independence. Since we're doing the chi-squared test of independence, well, that means the null alternative are independent. So maybe some good ways to remember, Nicole, is if you're doing the chi-squared test of independence, the null and alternative have the independence in them. So that's what we have right there. Is expected cell count. Jackie, you are right. Great question in the chat. The third condition would be expected cell count. And there is technically no real order to them. I just like to put them in order to help remember them. Count data, great question, Joe, means that both variables are categorical. Gender is a categorical variable, meaning it has categories. Broken bone is a categorical variable, meaning it has categories. Since both variables are categorical, we meet the count data condition. Probably the quickest way you could answer on the test would be gender is categorical, broken bone is categorical, we have count data. Because you're saying that it takes two categorical variables to make count data. And why do we call it count data? It's because, well, there's maybe 500 females who have not broken a bone. So now we're counting the individuals in each group. We're counting the amount that are in each group. It's a count of how many meet each condition. 500 females, I'm making that number up just to give an example. But if we wrote two categories, would that be... Jessica, I don't quite understand. If we wrote two categorical variables, would that be expected? So there is the expected cell count condition for this. All conditions for this test would be random, and randomness also has the independence assumption, but usually we just like to put randomness on the test. We don't, sometimes your assignments will talk about the independence assumption, but if something is random, you assume independence, so we just talk about random. 10% meaning you've sampled less than 10% of the population. And then the third condition, which there are no real orders, but I like to put them in order to remember them, is the expected cell count condition, meaning that all expected cell counts are greater than or equal to 5. And then the fourth condition is count data. If we wrote two categorical variables, would that be accepted? Yeah, yep, great job. And Nicole, thank you so much for clarifying there. With the expected and the accepted, I was like, wait, expected cell count? So thank you so much. Yes, if we wrote two categorical variables, that should be accepted. And please pick up your test to review them, because if you write something, us as the instructors know exactly what you mean sometimes. We put out a key for the TAs, but it's hard to put like every possible way a student could word something. If you word something a little differently and we know what you mean, sometimes the TA might not. We have great TAs, one of them was here earlier, but we've been teaching these courses for a long time, so we're more likely to catch something and be like, yeah, I know what they mean by that. So awesome, great job and great questions in the chat, thank you. Let's see, is it story time again? That's what it is. What is the missing p-value? We're doing some p-value calculations right here. So if you notice, I did say we'd have something like this. How do we find that missing p-value? Well, I put the technical answer right down. Did you go over the in-class review in your previous test review? I think I did. I think I went over a lot of, I've got the practice test posted where I go over the practice test, so make sure to check that out. And so this one is down to the decimal place accuracy. I did it, there's a few ways to do it. I did it where you divide this one by 2. So the less than test right here would add up to, you're welcome, thank you for all the questions, keep them coming. So, and if you can't find anything, email me, I'll put my email in the chat again. Email me at the following, and if you can't find something, be like, hey Brian, do you have a video for this? And every once in a while, I do have time to make more videos. I know we're in the middle of the weekend. We'll be taking the exam 48 hours from now. I don't know if that's good or bad. Exactly, Anna, amazing answer right there. And if you notice, there's one answer that's basically that. Thank you for doing that right there. Can you take 1 minus? Yep. And I did it where I divided this by 2. It's just decimal differences. I should have maybe changed the output in this because it's like, it looks a little bit weird, but there's decimals in the background where some rounding is happening. So I think everyone's figured out the answer that they know the less than and the greater than must add up to 1. That's what people are saying in the chat right now if you're looking at the chat, that the less than p-value and the greater than p-value add up to 1. And then I did it the way that the smallest p-value is double. If you double the smallest p-value, you get the two-sided, and if you take half the two-sided, you get the one-sided. So that is the answer right there. Great practice in the chat to figure out how to do it, and I did it the way of taking half the two-sided to get the one-sided. So, and technically it would be this hand right there, because it was a two-sided and I turned it into a one-sided. I'm just mirror imaged, or I'm used to be mirror imaged. Continuing on right here, let's do the next question. What are the 3 things that control power? Not the one used to solve power. Be careful. It's not the one we use to solve for power. What are the 3 things that control power? So let's talk about these 3 things. I like to talk about playing my brother in basketball. I try to change up the examples because I've given these a lot. My students have maybe heard them. But imagine you were to watch me play my brother in basketball for either a minute or an hour. Now, which of those tests would be more powerful? And by power, we mean the ability to reject the false null. So the ability to reject the false null, the null would be that we have the same skill. Oh, is it? Wait, people are doing F in chat. Did we lose volume? Did we crash? Oh, yeah, that's a good. Okay, good. Okay, there's F in chat for respect. I don't know. Okay, good. Scare me in the chat. Okay, so if I were to play my brother, okay, good. I got trolled. I definitely got trolled. I was like, what's going on? I thought the volume went out for a moment. I was like, oh no. Oh, okay, good. We're good. So I'm gonna get back on track here. I will say I have reviewed this quite a few times. Definitely check out the review yesterday, but it would be a more powerful test if we increase the sample size. So that definitely controls power. Now, alpha also controls the power of the test. So, oh yeah, I just thought it was like, we can still take the test to review assignment 2. I can't remember if it's open. It might be still open. The 3 things that control, I'll check that out later, Jillian. Good question. Oh wait, whoa. What just happened? Oh, Jillian, I'm going to make you, I have no idea what Streamlabs just did. Wow. Emily, what happened? Okay. I think it was just a joke right there. Don't worry, Rodo. Yeah, don't worry. I made Jillian a mod right there. I think I have the thing on Streamlabs just in case someone were to come in here and start saying craziness. Streamlabs should be able to jump on it, and every once in a while. So Jillian, you're a mod now, and I think Vicarious was just didn't realize what he meant in chat. So don't worry about it. Sorry for the confusion right there. It's fun broadcasting online. We don't usually. Jillian, you'll be back. Jillian, can you type again? No, you're fine. You're fine. You're a mod now, so you can type. And Streamlabs just, I wonder what it saw that it thought. That's weird. Are there questions about power? There are three things that control power: alpha, sample size, and effect size. Alpha is the amount of time you reject the null, usually set to 0.05. Sample size is the amount of sample you take. So if you were to watch me play my brother longer in basketball, it'd be easier to reject who is better. Like, you would think that we're the same, and it'd be easier to reject the null if we're better. Good to see you, Julio. Now I'm repping New York today. And then over there on the far side, we've got effect size. And the effect size is like when I play my brother in basketball, or I play my friend, who's my friend today? Dwight Howard. I play Dwight in basketball, and he comes over and just destroys me in basketball. Would it be easier to see who's better in basketball when I play my brother or when I play Dwight Howard? Who would it be easier to see who's better in basketball? Brian versus Darren or Brian versus Dwight? When is it easier to see who's better? When is it easier to see who's better? Is it the same? That'd be awesome. Apparently, my brother and I are amazing at basketball if it's the same. Dwight, people are saying Dwight in the chat. It'd be easier to see that Dwight is better, and why is that? Well, Dwight's amazing at basketball, and he's got those amazing dunks that he's got. I think he puts on the Superman, does some dunks, and so the effect size is larger. You could still watch us for the same amount of time, but it'd be easier to reject the null and say Dwight is better because of the effect size. The effect size is the difference between the null and the truth. The null is that Dwight and I are the same, but the truth is that he's way better. So since he's so much better, it's so easy to see that you would reject the null like that. Now my brother and I, the null is that my brother and I are the same. The truth is that my brother's a good bit better, but nowhere near how much better Dwight is than me. So it'd be harder to reject the null. Oh no, don't judge him by his 2K10 skill, 2K20 skills. Don't judge him. You know, it'd be so cool to be in a video game, like to be like, you actually like playing basketball or baseball and be like, that's me in the video game. Power increases when all three increase. Joe, amazing answer in the chat and ask those questions. Yes, if you increase alpha, you increase power. If you increase sample size, you increase power. If you increase effect size, which I can't point to over the screen, you increase power. So what do these make go down? All of these make beta go down because the equation for power is 1 minus beta. So power equals 1 minus beta. So if you make beta go down, you make power go up. So that's the trick. All of these are beta, all of these decrease beta, and the equation for power is 1 minus beta. So with this right here, we can see what is going on. Any other last questions about this one? These are all three things that impact power. So if you want to get a more powerful test, you could increase the sample size, you could increase the alpha, but we generally cannot change the effect size because I can't make someone better than me at basketball. I mean, they already are, but I can't make them. Let's continue on. Swift Tiger's still in the lead. What condition do you need 5 of? What condition do you need 5 of? Do you need 5 count data? 5 nearly normal? 5 success failure? 5 expected cell count? What condition, and this is one of the ones I changed this morning, so hopefully that's the right answer. What condition do you need at least 5 of? And success failure we need 10 of, and that's when we have one categorical variable. We need at least 10 successes and at least 10 failures. So if you think with 2 categorical variables, when you have count data is not the answer, you would need at least 5 expected cell counts. It's just the way we work the mathematics, and it's the way it works out that we need at least 5 expected cell counts. So there's the answer. Expected cell counts is found via the formula row total times column total over grand total. Exactly right, Julio. Good answer in the chat. We have the expected cell counts, and we want all those to be greater than or equal to 5. That is the chi-squared test of independence, which also has the condition count data, which means both variables are categorical. Keep those answers in the chat. I love seeing that everyone is following along. Write these things down that I'm saying. No, do it. You're fine to give the answers in the chat, especially early. Don't do it too early, but no. Give the answers, do the practice, and let people see it, because later on people use this to review, and I love seeing the answers in the chat. If you're typing an answer, you won't be as quick, so don't worry about giving away answers. No, you're back. Sorry, there was a little bit of confusion over that. You can still type. You are still good. You are perfectly fine. So there you go. Sorry about the confusion. No, it's just confusion. I want everyone to participate. What is the type 2 error? Okay, wait. So we need to know what the null and alternative is. You ready? The null is healthy tree. The alternative is sick tree. Okay, so in a type 1, the null is true, and we reject it. We're not doing type 1 here, though. In a type 2, the null is false, and we fail to reject it. I want you to look at that null right now, and I want you to think, the null is false. Be looking at that chat and be like, okay, the null is false. It is false that the tree is healthy. Just be saying that. Okay, so if it's false that the tree is healthy, the tree is actually sick. But what are we going to do? In a type 2, the null is false, and we fail to reject it. So I'm going to still believe. Now I'm going to fail to reject the null. I'm going to still believe that the tree is healthy. So if I believe that the tree is healthy, if I believe that the tree is healthy and it's actually sick, what's going to happen? We got the fun image up there to help us out. I swear that looks like my aunt's house. Like, is that a picture of your house? So we've basically given away what a type 2 error is. No! So a type 2 error, I'm just going to say it, is when the null is false and we fail to reject it. So the tree is actually sick, but we're going to fail to reject that it's healthy. So we're going to believe that the tree is healthy, but it's actually sick. The null is false. It's actually a sick tree. So you leave the tree up and it falls should be the right answer. But you might have done a type 1 error. In a type 1, the null is true and you reject it. So if the null is true in a type 1, then the tree is healthy. It is true the tree is healthy, but you're going to reject that. So the type 1 error would be to cut down a healthy tree. So the yellow answer is a type 1 error. I can't really point to it. I go off the screen. The yellow answer is a type 1, and the blue answer is a type 2. So be practicing these. Be thinking of other examples. I made up new examples here for this. I usually use like things like cheating, or I use like sick, or I use like scurvy with pirates for my examples. But be thinking about these examples and be trying to practice how to do a type 1, type 2 error. It's very easy to reverse it. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. And then look at that null and be like, it is false that the tree is healthy. That means the tree is sick. But I'm going to fail to reject that the tree is healthy, so I'm going to still believe that. So I'm going to believe the tree is healthy and it's actually sick and dies. So good stuff, good practice. Continuing on, Happy Zebra. Wait, Happy Zebra just beat out Swift Tiger. Maybe I missed that last time. Wow, Happy Zebra. Poor tree, no. Find the missing p-value. Nice and easy question right here. Oh, we got it. We got this. We should know that when we get the p-values, there's 3 p-values. The less than and the greater than add up to 1. And then, so that's less than and greater than a certain number. And then the two-sided is double the smallest. The two-sided p-value is double the smallest p-value. So that one should give this one away pretty quickly, and we should see some answers in the chat giving away that the two-sided p-value is double the smallest. I think I'm pointing to the right answer, but I think we're good on that one, and we are. I'm trying to think what else I can say about this output. This is a 2-sample t-test. If you're watching this, know that's a 2-sample t-test because we're doing the mean of male minus the mean of female. We talked earlier about this difference. The difference is negative because females had a higher sample mean. The t-ratio is the difference divided by the standard error. The degrees of freedom is a complicated formula. Yeah, pretty much a lot of this will be on the formula sheet, not how to get the p-values. The p-values you should know, not like literally how to get them, but that the less than and the greater than add up to 1, and also the two-sided is double the smallest. Is that what you were asking about, Joe? You will get formulas for the t-ratio and the confidence interval. Those formulas will be there. So you'll have a formula to find these, and you'll have a formula to find this. You will not do the degrees of freedom formula for this one. That's a complicated formula, which we will not do, but it's a very long, like s squared, n1 squared, n2 s squared, all those things. So all of that right there. Keep those questions coming if you have them. All those things I want you to know and be ready for the test. Happy Zebra still, Swift Tiger, what's going on? Zany Ant is catching up and Ant's leading the way. Oh my gosh. What are the degrees of freedom for the t-interval? We got this. If you should know this pretty quickly. It's not that complicated formula one we just saw. The complicated formula is for a 2-sample degrees of freedom. But we've done a lot of the different degrees of freedom today. We did rows minus 1 times columns minus 1, but there's no rows and columns here, so this is not the chi-squared. We did the 2-sample t, which is a complicated formula, which we're not going to solve by hand. But for the 1-sample t, listen to the formula. It's n minus 1, and we see n right there, and we do minus 1. And doing n minus 1, 770 minus 1, we get 769 right there. The complicated formula is for the 2-sample t. We will not solve that by hand. We usually use applets or let software solve it. Is it at the end of? It is, I'm going to post it probably later tonight and say, here's the current formula sheet. It's very similar. We did some updates to make it look a little better and maybe a little easier to read. And I'm going to ask all the instructors, Anna, thank you very much for the answer in the chat. N minus 1 is the degrees of freedom for a 1-sample t. And I'll probably send out the new formula sheet later tonight, or I'll post it on the review thing. And it'll be like current formula sheet for exam 3, so people can look it over and make sure to understand. I'd probably be doing that tonight or tomorrow, looking over the formula sheet and be like, okay, this is this, this is this, this is where I'd use this here, and that'll really help out. So good stuff. Great questions in the chat. Let's continue on. What is the alternative for this test? What is the alternative for this test? Oh, we got this. Wait. Oh, I was blocking it, I think. Yep. I was blocking it. That's a big hint. Here, I can go this way. I can still be on here, the screen this way. Yeah. Oh, don't want to block it. Basically give away which one it is. I think this is one of the easiest questions. I know I've covered this question a whole lot, but this is one of the ones where when you get to it, you should know you're not using statistical notation. And maybe hint. We put between the two words, so I'm going to kind of block the answer now, but we put between the two words that gender is independent of breaking a bone. That's the null hypothesis. And then gender is not independent of breaking a bone. So the easiest way to remember this is the chi-squared test of independence. This is the only test where you will use words and not statistical notation. In other tests, you will write p equals some value, mu equals some value, mu1 minus mu2 equals some value. Practice writing those down. Literally just writing things down or saying them out loud is a lot better than watching me do it. Some of the people who've told me they do well in the class are like, I write these down, I practice them out. So please write these things down. Write p equals p naught, and then know that p naught is the hypothesized value. Write mu equals mu naught, and then know that mu naught is the hypothesized value. Write mu1 minus mu2 equals 0. Write x is independent of y, and x is not independent of y. And then put your x and y in context of the problem. Don't just write, and I want to say that someone's going to write x is independent of y on the test. That is the null, but make sure you give it the context of gender is independent of breaking a bone, which is the x and y in context. Great stuff. Zany, I called it. I'm clairvoyant. I called it. Zany Ant leading the way. What is the null hypothesis for this test? What is the null hypothesis? We got this. You guys should know instantaneously the null has the equal sign. Every once in a while we've done a multiple choice, and you should definitely love if we ever did a multiple choice on this test for the null. Once again, please note my trick for this is to write, this could technically have mu male minus mu female. Maybe I could have done that, but I just did the general mu1 minus mu2, where mu1 is the mean for males and mu2 is the mean for females. I know, easiest one. This is a really good one. It's like null has the equal sign, got it. And remember, the only time you use words is when you are doing the chi-squared test of independence, at least for our class. The only time you're going to use words is for the chi-squared test of independence. Because it's the chi-squared test of independence, make sure to do x is independent of y and give context to x and y. And what do we see right here? Think about what this null says, is that the difference between the two is equal to 0. And you know what's interesting? Look at the output. What is at the center of this curve that is most likely if the null is true? If the null is true, the most likely value to see for the difference is 0. So we actually see the null value at the center of the curve. I did the question was supposed to be easy unless you... I'm sorry, Ryan, I'm sorry. See, I'm sorry. They said that they were trolling me for a second, but I think I trolled you guys. I'm sorry about that. But Great job on the chat. And thank you for everyone for being here. I know it's midday on a Saturday. People are probably going to watch this later. Be writing these answers down. Thank you guys. No, we're so glad to have you guys here. And we're on to the last question. I said we'd be ending about 1:30, and that's a good spot to end. I'll probably take some questions. You're with Ryan. That's Zany Ant. What people put, if you were caught in the blue, I'll have you put your place in the chat and I'll pick the winner from who's, and remember you can come to my office hours, I'll be holding some office hours this week, but if you put your place in the chat, if you were caught in the blue, and the highest person in the blue is going to be one of our winners, and I'm just going to do that with my hair constantly, but the highest person who is in the blue will be one of our winners. Which of the following must be met for the chi-squared test of independence? We should have two answers right here. It's a good spot to end on. Know your conditions. If you notice, I focus a lot on things we can memorize. So I want to give some parting advice because people might stop watching after the Kahoot. The review I did yesterday focused a lot more on solving mathematics. The Kahoot right here is a lot more focused on memorization, especially conditions. I obviously can't cover the whole class in an hour and a half. Like, it's like, if I could cover everything in an hour and a half, then that would just be like, well, why not just hold one 90-minute session and then you'd know the whole class? It'd be really hard to cover every bit of material. But I focused today a lot on memorization stuff, on how to read certain output. And yesterday I did a lot of the equations. And so definitely look at both those. Look at the equations from yesterday, look at where I'm solving problems. Also, I did a video where, and a lot of people said they liked that video, where I went through how to do each test for each chapter. So I went through and did the one proportion test. Look up this video. It's one big video and I might start splicing that video to different parts, but watch those videos, practice writing these things down, and those are the last three conditions right there for the chi-square test of independence. Success failure is for categorical data, one proportion test, and nearly normal is for one sample mean and two sample mean. That was the hypothesis review there, Alex. You are correct. And I go through and I do every single test, starting off with the one proportion test, the one sample means test, the two sample means test, and also the chi-square test of independence. And we do all those for about, I think it was right over 2 hours, I think. I really want to thank you. You're so welcome. You're so welcome. Sorry about the thing there. We want to make sure, and we appreciate it. I appreciate you guys being here. Say your place in the chat. If you were caught in the blue, give your place in the chat. And be like, if you were one of the people who got hit with the blue, and I'll pick the winner from that. So second, well, you're definitely a winner. Thank you. Yes, so welcome. So Madeline, you are, Madeline, if you were in the blue and you got second, then you definitely won. Oh my gosh, sorry, Swift Tiger. Is that what is that called when you write in that structure? That's pretty good right there, Matthew. That's pretty good. Can you show the interpretations? Which interpretation do you want to see, Joe? Which interpretation would you like? It's a haiku. That's what I was thinking. I think it is a haiku. It's a ballad. It's the Ballad of Swift Tiger. The Ballad of Swift Tiger. I like it. That was really good right there. Yeah, I was looking at structure, like haiku structure. I don't remember. That's the way it should always be. That's the way it should always be. I can exit out a full screen right here and we can show that Kahoot code. Oh, there's the Kahoot code. And what I need to do is I need to fix my window here. I actually, main screen capture. So sorry, you're seeing behind the scene. I can just be like, whoa. Whoops, wrong button there. I'm gonna fix the window so that there we go. And I did some editing on my window right here. That way we wouldn't be showing off the screen. So before the Kahoot, I made sure that we really wouldn't do that. The chi-squared, the interpretation, what was it? Can you show the which interpretations for the chi-squareds? Which interpretations of the chi-squared? Is that not clicking into place right there? There we go, that's good. Okay, good. Let me lock that down. All right, we're good. We're locked in place now. Which interpretations? Here, I'll pull up jump right now. Is that jump? Did I click jump? I clicked jump. Let's do a chi-squared right here. Let's do a chi-squared. I'll definitely answer some more questions. Let's do a chi-squared. Thank you, everyone. So the chi-squared, if you notice, we have to write out a quantitative answer, qualitative answer. Go into a little greater detail on the question. I'll do a chi-squared test right here if I find my mouse ever. Where'd my mouse go? Everything is so crazy. There we go. let's see. Let's do, if someone has student loans and if they're in the honors program, so we're going to do the chi-squared. There we go. So if swing by my office and I think I might have 3 Starbucks gift cards left. We definitely we got our person in the blue who won, and I might have 2 10s. If I have a 5, definitely going to you. So first 3, top 3, come by, tell me your place. I should have it, and so I should have, I think I have 3 Starbucks gift cards left. Come by, swing by, pick those up. Example for the confidence interval. Those are only for confidence intervals. Like those, I am blank % confidence would be for, I'll show you those. Here we can do this. We can do 2 of them right now. Here we go. Here are 2 confidence intervals. So this would be, here's 2 95% confidence intervals. These are 2 different variables though. So I am 95% confident the true mean age of UT students is contained in the interval 19.66 to 19.90. I am 95% confident the true proportion of males in Stat 201, maybe we should say in Stat 201, is contained in the interval 43.94 to 49.34. Is the test going to be roughly? Yep, it is. It's like interpretation and then also mathematics. So you do have to know how to solve equations. We had a lot of good stuff with like the observed and the expecteds. And if you notice, I've got confidence intervals right here for basically how to do it. Happy Zebra wants to know if there's a pride for third. Yeah, there. As long as top 3 should get it. I think we had like ant, zebra, and swift tiger. So come by, tell me your place. If I've got it, I'll give it to you. So if you're like, hey Brian, I was in this place, send me the picture of it just so everyone comes by, like 10 people come by, like, and I was in first place. I'm like, what? I've already had 5 people come by and say they were in first place. So if I have it, I'll definitely give it to you. I've got a video on how to get to my office on YouTube. Just Google Stat 201 UTK Brian's office. And if you can't find the video, then email me and I'll send you the video. My email is bstevens@utk.edu. If you can't find where my office is at, email me and there is the video on the YouTube channel on how to get there. So we don't have an interpretation for a confidence interval for the chi-squared. This is a proportion up there. That is a test for proportion. Well, thank you very much. I appreciate that. And then we have right over here on this output, we have a confidence interval for the mean. So this is the output for a proportion. This is the output for a mean. And then we've seen this a lot throughout today. We have the output for 2 means where we do like born in Tennessee and we do like, let's do, I'm trying to think of one that's going to be halfway normal. Let's do tip percentage. That's a funny one. There we go. It's a little skew. Got some people saying they tip 100%. So born in Tennessee, tip percentage. You're welcome. Definitely enjoy that. So who tips more, the people born in Tennessee or the people not born in Tennessee? This has been on the test before. Who tips more, the people born in Tennessee or the people not born in Tennessee? Who tips more? Can you tell me by looking at this output, who had a higher tip percentage? The people born in Tennessee or the people not born in Tennessee? I don't know. How many people do we still have watching? I'll cheat and look. The answer is, and we got 33 people watching, good. The answer is that the people not born in Tennessee tip more. And they tipped 0.34% more, not born in Tennessee, because the second number is because it's negative. We did this earlier. It's like 10 minus 12 would be negative, 12 minus 10 would be positive. Since this is negative, then the no had a higher sample mean. And what you'll notice here, here's a few things we have not mentioned in today, but notice what is contained in this interval. What value is between 0.34 and negative 1.0? What value is between negative 0.34 and negative 1.0? Now, if you average them, you will get the center of the interval. But what value is between them that's an interesting value? Jessica, you are right. 0 is between them. Meaning, remember, the null is that there is no difference. Mu yes minus mu no equals 0. That means you can't reject 0. And that is with the two-tailed test. We just did another concept right here that on the two-tailed test, we cannot reject the null hypothesis. That's because the interval contains 0. So at the 0.05 alpha level on the two-tailed test, we cannot reject the null. You can also see I do like, oh, can I not do the power test on that or the p-value test? I'll do it in another spot. I'll show you this right here. Let me do a test. Okay, let me test a mean. Let me test 19.75. Oops, did that? I typed in a comma and it destroyed it. Test a mean. 19.75, and oh, looks very similar. I like it. So now I'm going to do this. I'm going to do p-value animation right here. Good deal. Now I want you to notice that this line is where our sample result is at. If I go below that line and I go above that line, that is how we get that the less than, the greater than tests equal up to 1. These are all one-tailed tests or one-sided tests because you're just shading one side of the curve. So the less than test and the greater than test add up to 1, and they're called one-tailed or one-sided tests because they shade one side of the curve. But then the does not equals test is a two-sided test or two-tailed test because it shades the two tails of the curve. So this would be the p-value for the does not equals, which is double the smaller of the two. All you do is reflect it on the other side, and that is doubling it, giving you the p-value for the two-tailed test. So all that good stuff right here, you can see these p-values are high. I'm kind of covering them right now. But the p-values for these tests are high, meaning that we cannot reject 19.75. Now 19.75 being the hypothesized value is inside the interval. So if 19.75 is in the interval, we cannot reject it because we're saying, well, maybe 19.75 is a value. And I want to say one last thing. I think is a great question in the chat too. This is why we do not accept the null. People might say here, Brian, why can't we just accept the null? Don't say those words. Don't say those bad words. Because imagine if someone put 19.8. I want you to tell me, if you were to say, I accept 19.8 as the mean, well, then you also accept 19.75 as the mean. What we're saying in statistics is, I cannot reject those. Those could be the mean, and that's how it works with the confidence interval. The confidence interval gives you possible values. You're saying, well, I'm 95% confident the true mean age of UT students is contained in the interval 19.66 to 19.903, so those are possible values. If I were to test those values, I would not reject them on a two-tailed test. So don't use that bad A word. You're not going to accept those values. Don't say that word. You're going to not reject them or fail to reject in classical statistical wording. You're just saying, well, I guess that's a possible value, and I would not reject it, or fail to reject, same words. If it's only shaded the left, it'd be a greater than test. So if you notice this one right here is shading, it's a greater than test. That is when you say that mu is greater than 19.75. And if you notice where we landed, I can show you where we landed. We landed, if you look at our result, 19.78. That is that red line right there. And the p-value right here of 0.275 is this blue area right here, that dark blue area. Both of these areas are the does not equals test, which is double, and there's some decimals going on in the background we can't see. But if you were to double 0.2796, you would get 0.5591. And there's some decimals that I know you might say 0.5592, but just decimals in the background we can't see. Great questions, Joe. Keep asking them if you have it. That is how we've looked at the different output for the one sample mean, the one proportion test, and then we did the two sample mean in the background right here. Here's the two sample mean output, and then we also have right here the chi-squared output. And don't worry about the Fisher test. We're not going to talk about Ronald Fisher today. But we have here the test, and if you notice, this is the Pearson. And if you want to test yourself, you can always go in here after making one of these, and you might still have the Survey 19 data. You can go right here and remove. Good, I've just got the counts in. You can go in here and put in these values. And if you notice, I did deviation instead. I didn't want to do, I'm going to click all the wrong buttons. That's my goal in life, is click every button I don't want to click. There we go. If I were to add 0.3362, 0.4273, and 3.3905, and 4.3008, I'm adding together all the cell chi-squareds. What would that add up to 3 decimal place accuracy? If I were to add all the cell chi-squareds, what would that add up to with 3 decimal place accuracy? What would that add up to? Does anyone have any ideas what that would add up to? If I added up 0.03362, 0.4273, 3.3905, 4.3008, that would add up to exactly. What did it add up to? The sum of all the cell chi-squareds is the Pearson chi-squared test statistic. That's how this number is found right here. It's the sum of this number plus this number plus this number plus this number equals that number right there. And then from that, we find our p-value. The p-value would need to be graphed out. We might have questions where you'd be looking at applets on the test. So make sure you look at the applets that are posted to the site. I did some review of those applets yesterday. So take a look at yesterday's video if you're still watching right here. But we'll see, are there any last questions in the chat? If you look at this, I can write my null and alternative pretty quickly. Being in the honors program is independent of having student loans. That's the null. Being in the honors program is not independent of having student loans. That is the alternative. So you just put between the two things independent, and you just say honors program is independent of having student loans. Honors program is not independent of having student loans. You might have to add a word like having student loans to make it a little more logical, but if you probably said honors program is independent of student loans, we would accept it because that's what you're basically saying. Last few questions, last opportunity, give those questions if you got it. Type it out and hit enter and be like, wait, I think we are good. Email me those questions if you have them, and it is time. Let's end with good old Crash Bandicoot.
Yeah.